Hey, environmental science students. We're going to do some population density calculations, and these ones use unit analysis. So some of them have the scaffold for you with the little spots set up, like this first one I'm going to show you. If a certain species of monkey has a population density of 5.4 individuals per square kilometer and inhabits an area of 210 kilometers squared, how many monkeys are in this population? So we're going to have to look for monkeys as our units for the answer. So we'll put that in here. And that means I'm going to end up needing monkeys on the top, and the other units that I need are going to have to cancel out. Zoom in so I can write that. So my other units are square kilometers, which are km to the second power. So I have an area of 210 kilometers squared, and I have 5.4 individuals or monkeys per square kilometer. So I know that the 5.4 goes next to the monkeys, and that's per 1 kilometer squared. And the 210 kilometers squared must go in my other spot. So this spot is going to be area, and this spot is our population density. So now I have it set up so that my units will cancel out, and I'll end up just with the number of monkeys. So I'll just do that off to the side here. 210 times 5.4, which equals 1,134. Okay. So let's see how else we could use population density to solve some problems. This one does not have the scaffold for us, the little area set up, but you'll set it up the same way, a similar way. You have to kind of think about it. So first we have silver carp, an invasive species in a river in North America that has been observed to have a density of 1,030 fish per square kilometer. So you can see that and think to yourself, I have 1034 fish over 1 kilometer squared. I'm going to have to use that somewhere. First, it's giving me dimensions of the river and asks what is the area of the river habitat. So we're going to be looking for kilometers squared, and the area is just the length times width. So 360 kilometers times 0.25 kilometers. Even if you know that this is how you set it up, it's a good idea to practice writing out how you would show your work if you would need to do that on the AP exam. And I'm just going to do that calculation off to the side here. So 360 times 0.25, and I get 90 kilometers squared. Okay, 90 kilometers squared. So that goes in this blank. And then how many carp are in the river? So remember we wrote down already the population density of the fish, so you can use that again. So just like we did in the other problem, if it gives us an area, which we have now, 90 square kilometers, we can set up our own little unit analysis problem where we have 1 kilometer squared on the bottom and 1,030 fish on the top, because when we set it up like that, our kilometers squared will cancel each other out and we'll just be left with fish. So I'm going to do that off to the side. 90 times 1,030, and I get 92,700 fish, and the units for that were fish. Okay. And then one more question that we continue using unit analysis for. If the average carp weighs 5.9 kilograms, how much carp biomass is in this river at a given time? So we're going to use this 5.9 per fish as our unit. A little tip is anytime you can think of a number as per another number, so here's our fish, setting this up, you can use it in a unit analysis problem. So 5.9 kilograms per one fish. And then I can see that fish will cancel out on the top and bottom. And I can take that answer that I had earlier, multiply it by 5.9. And I have 54 546,930, which is a lot. And if you've learned about invasive carp, then you know that they can kind of take over an ecosystem. Okay, so that's it. That's some examples of using unit analysis to solve these population density problems. My last tip is just to, again, keep looking for these per words to see when you should be setting up a unit fraction for a unit analysis problem.